Okay, we're starting a new chapter, chapter 6. This is going to be ELR 6.1. It's all on quadrilaterals. So here's your warm-up for today. Please sketch this box here with these headings. If you do or are able to sketch a pentagon, hexagon, and heptagon like I did, that I copy and pasted from the computer, please do so. So we're taking a look at each of these 3 polygons, and we're drawing diagonals from one vertex only, and then filling in the table below. So it's easy enough. You could pause, copy this table, see if you could figure out how many sides, how many triangles are formed, and then what would be the sum of the interior angles of each of these 3 shapes. All right, so if you take a look at my pentagon here, I'm going to draw diagonals from vertex A here. So I'm going to go from A to C and A to D. I can't go from A to B because that's the side of the polygon. So how many triangles do I have in a pentagon? I have 3. So I'm going to write 3 here. How would I figure out the sum of all these angles? Well, take a look. We have a triangle, which we know is 180 degrees. So I'm going to do 180 times 3 triangles to get the sum of what the angle measurements would be inside for a pentagon, which would be 540 degrees. See if you could do the other 2. All right, if I go ahead and do the same thing with the hexagon, 6 sides, I go from one vertex only. So let's see. We go from here to that one, to that one, to that one. How many triangles do I have here? I have 4 triangles, so 180 times 4 will give me the sum of all the angles. Oops, not 4, I meant 6, my bad, 6. That would give us 1,080. Keep going, see if you could get the next one. So I was mistaken. I was thinking about the sides, my bad. So again, let's just erase this here. I'm doing 180 times 4 triangles are in that 6-sided shape, which comes out to be 720 degrees total. For the last one there, for the heptagon, 1, got 2, 1, 2, 3, 4, 5. So that's going up by 1 each time for these. I got 5 triangles. So I'm going to do 180 times 5 triangles, which is 900 degrees. So looking for the patterns in this table, could you figure out the sum of the interior angles of a polygon, no matter how many sides it has? So if you notice here, it is going down by 2 each time here. So the sum of the interior angles for a polygon is taking n minus 2. That means the number of sides for the n. And I'm going to multiply it by 180 degrees, depending on how many triangles I have. So the sum of the interior angles of a polygon is 180 times n minus 2. All right, so today's objective is ELR 6.1. Students will be able to find the sum of the interior or exterior angles of a polygon. I just gave you the formula for the interior angles, which you already have written down, but we're going to go over it again, and we're going to talk about exterior angles. Once you've copied these notes down and submitted them to the Google Classroom, your homework is Math Excel 6.1. All right, so 30 seconds, pause this video. What's the difference between an equilateral, equiangular, and regular polygon? Here it is from the textbook. Equilateral, all the sides are congruent. Equiangular, all the angles are congruent. And a regular polygon is both sides and angles are equal. Equilateral and equiangular. All right, so let's get that formula down if you haven't. The angle sum of any type of regular polygon is taking the number of sides, subtracting 2, and multiplying it by 180 degrees there. So let's do these 2 examples. You could pause the video if you'd like. What is the sum of the measures of the interior angles of a 17-sided shape? So I'm going to do 180 times 17 minus 2. And that comes out to 2,700 degrees is the total for inside that polygon. Now, what if I told you if the sum of the measures of the interior angles is this. I'm giving you the sum, 1,980. How many sides does it have? So here you're using your equation, but working backwards. So I'm going to take my formula, and now I'm going to equal it to 1,980 and solve that for n. And when I do that and solve it for n, I get it to be 13 sides. All right, moving on. What if I want to find just one inside angle of a polygon? What would I do? So here's an example. Find the measure of an interior angle of a regular nonagon. A nonagon has 9 sides. So I'm still going to do the same thing, 180 times n minus 2. But the extra piece here is that I'm going to divide by how many sides I have. I'm going to divide this by 9 to get what one angle is inside. So one interior angle is 140 degrees, just one of them. And here is the formula. If you want to write it down, the measure of each interior angle of a regular nonagon is doing the 180 times n minus 2 divided by the n. So that's just that extra little piece there. All right, moving on. Let's talk about exterior angles, the outside angles of a polygon. We'll want to find the exterior angles of the following, just like the triangle. So if you take a look at this triangle here on the right-hand side, they have the 3 angles inside in black. How are they getting this 80 degrees out here? Well, it's a linear pair because it's on the straight line. So they're doing 180 minus 100. Same thing for this one. They're doing 180 minus 30. And the same thing for this one. So what I'd like you to do is copy down this 4-sided lovely thing, polygon. We have 65 degrees, 109 degrees, 105 degrees, and 81 degrees. What I want you to do first is get those 4 outside angles by taking each and subtracting them from 180. All right, I got all 4 of those angles. So what do you notice about the sum of the exterior angles of a polygon? Pause the video, see if you can figure out, and then come back for the answer. So hopefully you notice that when you're adding all the outside angles for either the triangle or this 4-sided shape, it is 360 degrees. I could keep going on and trying this for a 5-sided, 6-sided. It works. It will always add up to 360. Why do you think this is possible? Just think about it. As you make a larger and larger polygon, let's say 100 sides, it's almost going to look like a circle. So that's why all the outside angles of a polygon add up to 360. So here's the theorem. This you could write down. All of them always have to add up to 360 degrees. We're going to take a look at these 2 examples here. We're talking about a dodecagon, which has 12 sides. So go ahead and pause the video, try these 2 examples, and come back to see if you have the right answers. All right, so for question 1, to find the measure of an outside angle of a dodecagon, well, we know they all add up to 360, so I'm just going to take 360 and divide it by the number of sides, which is 12. So each exterior angle is 30 degrees. Number 2, there are 2 different ways you could do it. I think the easiest way to find the measure of an interior angle of a dodecagon for 12 sides is if I know the outside angle is 30 degrees, I could get that angle, right, that's inside of it. Think about it, right? I'm not going to make a 12-sided shape, but if I know that the outside angle is 30 degrees, I could get this inside angle from what we did from the previous slide by doing 180 minus 30. So each interior angle is 150 degrees. All right, let's do this example here. Almost done. The measure of an exterior angle of a polygon is 72. Find the measure of an interior angle and how many sides. Pause the video, come back to see if you have the right answer. All right, so I'm going to do 180 minus the outside angle. So my interior angle is 108 degrees. How many sides does it have? Well, if I take 360, because they all have to always add up to 360 on the outside, divided by the 72, I get it to be 5 sides. All right, here's our closure for today. So our objective today was to find the sum of the interior and exterior angles of a polygon. Let's take a look at this polygon here. How many sides does it have? 1, 2, 3, 4, 5. It has 6 sides. And they're giving us the angles on the inside as expressions. So let's figure out what is the angles of a six-sided shape all have to add up to on the inside. So that's that formula that we're doing, 180 times n minus 2. So the sum of the angles here, all of them have to be 720 degrees. So I'm going to write my whole expression out. I'm going to take all of these and add them up to equal 720. Be careful of your like terms here. So I'm combining all my x's here. And then I am combining all my numbers. Be careful of the signs as you do this. So after I combine all my like terms there for my x's and my numbers, I get it to be 52 x's minus 8 to equal 720. I solve that two-step equation for x, and I get it to be 14. So after you've taken these notes, you're either going to scan or take a photo of them and submit via Google Classroom. Math Excel 6.1 is due for homework for next class for next week.